Modern cosmology, the study of the evolution of our universe, depends on the existence of dark matter. According to astronomers, galaxies, the great star islands that are the building blocks of our universe, start to form due to accumulations of dark matter. So our cosmos is thought to be filled with dark matter. But AGC 114905 provides a different explanation. Researchers spent 40 hours examining galaxy AGC 114905 with the state-of-the-art Very Large Array Observatory in New Mexico. But, still, there was no sign of dark matter. Another dwarf galaxy NGC 1427A, while passing through the Fornax galaxy cluster, experiences perturbations that are not feasible if the galaxy were encircled by a dense and wide dark matter halo, as needed by conventional cosmology. So, what does it mean? First, we will know when astronomers started to think about dark matter. In the 1930s, scientists were much more perplexed by galaxies' misbehavior. In 1933, a Swiss astronomer, Fritz Zwicky, studied the light emitted by the more than 1,000 galaxies that are part of the Coma cluster of galaxies. Zwicky determined the mass of the Coma cluster using two methods. One is the velocities of the galaxies and another is the total brightness of the cluster. Do you know the velocity of the galaxy is determined by measuring the redshift of spectral lines in the spectrum of the galaxy? This is the Hubble law that helps astronomers to determine the velocity. Then astronomers using the orbital velocities of stars, interstellar matter, and the distance of the stars from its galaxy's center, can calculate the total mass of the galaxy. The second method is that astronomers using the brightness of stars can determine the distance to the star. We know, according to Newton's law of universal gravitation, gravity depends on mass and distance. So astronomers using the distance can calculate the mass of galaxy. Then Fritz Zwicky compared the two resulting mass estimates. He found that the galaxy velocity measurement estimated that there is hundreds of times more mass in the Coma cluster than the brightness estimate predicted, and the extra matter was not emitting light. Then Fritz Zwicky said, if this would be confirmed, we would get the surprising result that dark matter is present in much greater amount than luminous matter. Those scientists consider the first type of evidence supporting the existence of dark matter has to do with the way dark matter affects the movement of celestial bodies. According to Newton's law of universal gravitation, every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It means, if the distance between two particles increases, the gravitational pull between those particles decreases. Just look at our solar system, you can see Mercury move too fast with respect to Uranus. Do you know, maximum mass is concentrated near our Sun. As Mercury is closest planet to our Sun, it moves fast due to strongest gravitational pull, but Uranus is far away from our Sun, so Uranus moves slowly due to less gravitational pull. But when astronomers looked at the distant galaxies, they find something odd. Scientists recorded the incoming light from a distant spiral galaxy and plotted the velocities of the stars versus their distances from the center of the galaxy. Do you know, in a galaxy, the brightest part is located at center, so it is assumed that the maximum mass of the galaxy is concentrated at center. So the objects closest to the center should move fast with respect to those that are far away from the center, but those objects that are far away from the center moves fast with respect to those objects that are nearer to the center. The only way this is possible is if there is more mass in the outer parts of galaxies than we can observe. The fact that we are unable to see this mass, because it is not emitting light, suggests the presence of dark matter. The third area of evidence supporting the existence of dark matter comes from a study of the Bullet cluster. Astronomers were trying to find mass of Bullet cluster through gravitational lensing. Gravitational lensing is based on the fact that the mass of an object influences the density of space around it. When light travels through this dense space, it bends. After determining the total mass of the Bullet cluster, astronomers found that most of the mass of the Bullet cluster is not located where the source of the X-ray emissions are originating, meaning it is not from the matter we can see. This is why scientists consider matter makes up less than 5% of the mass of the universe, and the rest of the universe appears to be made of a mysterious, invisible substance called dark matter. But, When astronomers looked at these dwarf galaxies, AGC 114905 and NGC 1427a, they realized they don't need dark matter to explain the motions of the gas in AGC 114905 and NGC 1427a. In AGC 114905, the gas appears to be in a rotating disk, and astronomers could measure the Doppler shift of the gas, which gives its velocity. From that, astronomers could derive a dynamical mass, and what they found is that it's essentially the same as the mass found using the galaxy's light. Then astronomers tried to explain with some dark matter models, but none fit the measurements except some parameters that has been changed in impossible way by astronomers. It means, it doesn't seem to have any, or at best very little, dark matter. Some astronomers thought any big galaxy near the AGC 114905 might have stripped off its dark matter, but there are no other galaxies. Do you know the observing angle on the galaxy is one of the major uncertainties? Though the galaxy is so faint that the angle is really hard to see by eye, the astronomers observed the galaxy face on, edge on, or somewhere in between. That changes the actual rotation speed of the gas. There's a trigonometric dependence on the inclination angle of the true velocity versus that measured. They find it's tripped by about 32 degrees, so a bit closer to face on. Then astronomers also find few ways to measure that and seem confident that's the actual value. The another galaxy, NGC 1427a, flies through the Fornax galaxy cluster and undergoes disturbances which would not be possible if this galaxy were surrounded by a heavy and extended dark matter halo, as required by standard cosmology. According to the standard model of cosmology, the vast majority of galaxies are surrounded by a halo of dark matter particles. This halo is invisible, but its mass exerts a strong gravitational pull on galaxies in the vicinity. So, if the dwarf galaxy, NGC 1427a, is surrounded by dark matters, the dark matter shielded that dwarf galaxy, NGC 1427a, from the disturbances created by neighboring galaxy. However, there are also 5 galaxies that appear to lack dark matter, and those all have different inclinations to astronomers. So does it mean that dark matter doesn't exist? Astronomers are still researching on those galaxies that don't need any dark matter to explain. But, it's still unlikely to cause astronomers to throw away the idea of dark matter altogether.